DBL Talks. My name is Mike. Joining me today is Daniel. We're interns here at Synergex, and we're very excited to bring you the third episode of DBL Talks.
That's right. In the last episode, we looked at the select class, which allows you to query your ISAM data. Now here we're going to be looking at IO hooks, which allow you to intercept those same operations. And we got a long road ahead of us.
Let's get to it. Okay, so what are IO hooks? At a high level, Synergy IO Hooks API lets you perform custom operations before or after a standardized IO operation. Think about it, for example, for either a read or for a write. For a read, you could possibly run a piece of code before it occurs, and you can even run a piece of code after the read occurs.
That sounds interesting. So why would you want to do that? What's the practical use case for this?
Yeah, that's a great question. The biggest use cases are if you want to stay transparent without changing your existing application logic. The use cases range a long way. There's anything from logging all the way to validation and so much more in between. The best part is that your main application code just keeps calling read and writes normally. It doesn't even realize the hooks are even present. The hooks are called automatically by the runtime, not interfering with your existing application, which is great for large legacy code bases.
All right, for our very first example with IO hooks, we're just going to be building a very simple logger program that prints the console before and after we do a reads operation. Now, in order to get started and working with IO hooks, we need to obviously import the namespace. In this case, we're going to be it's going to be called synergede.io extensions. And we also need to define our own class that inherits from the IO hooks base class. And in this case, we're going to be simply calling it logging IO hooks. Very simple, right?
Hold on, what's the parent channel call?
Yeah, you're right. Here you see it on line 7. And what it does is that IO hooks class needs to know which file channel it's hooked to. When we create our logging IO hook object, we'll simply pass it a channel number, and you'll see that in just in a moment. It's a constructor that just passes the channel number up to the base IO hooks constructor. Now to intercept an operation, we'll just need to override one of the virtual hook methods. There are a lot of them, so if you want to look at the full list, just look at our documentation. In this case, we're just going to be overriding the reads pre and post operation hook, which, as the name suggests, it inserts a hook before we do a reads and after we do a reads. Very simple. And here's what that's going to look like. Here we go. And as you see, we just do a simple console.write line before and after we do our reads. In reality, you can put whatever code you want here. So in this case, we're just going to be keeping it very simple.
Okay, so the class is defined, but how do we use it and how do we attach it to a file?
Yeah, it's surprisingly simple. In this case, we're going to be going away from our file and into our program that we're going to be running. So here in our login.dbl program, you'll notice already that we're using the employee.isam that we used in episode 2. We're going to be just simply reusing it here. On line 8 here, you can see that we're simply adding a example.logging IOhooks and just simply passing it the channel that we're using so that IOhooks can hook into that channel and do the operations that we need it to. Okay, now before we actually run this program, let's go ahead and add some breakpoints. So we're going to add one right here, here, and just so that the program doesn't close itself, let's add a breakpoint at the end here. Let's compile and build. There we go. Click continue. We have the pre-reads operation, and we have the post operation, and there you go, and the end. That's it. It's very simple.
All right, so far we've shown you how to attach hooks to a specific channel, but what if your application wasn't designed with a single routine in mind? That's where global IO hooks come in. Global IO hooks let you intercept every file open across your entire application inside a single global hook routine. You get the information such as channel number, open modes, and file name, and with that you can attach a hook. This allows much easier adaptation, especially for large existing legacy applications. With that in mind, let's head to the example. I'm going to quickly just copy and paste. See here, we still have import Synergex Synergy IO extensions.
So this runs whenever a new file is opened?
Yeah, exactly. After each file is open, the runtime calls this specific syn global hooks open subroutine. It grabs the channel, the modes, and the file name. Here we have it set to employee, just as we had it in the previous example. And it creates a new instance of logging IO hooks, which we also created in the previous example. Otherwise, we're just going to do nothing. And just to show it off really quick, I'm going to jump over into Program DBL. I have here blocked out the last new instance of logging IO hooks. So now it's globally going to run on the reads. And if I perform a debugging session really quick, let it just load up. Great. Give you guys this. As you see, we're back in the reads pre-operation hook. And if I continue to run it, we're going to run that. And we're going to do the same for reads post-operation hook. And as you see, without creating a new specific instance, I now, based on the file name of employee, am able to run IO hook operations just based on the file name, which is really helpful for legacy applications. With that in mind, that's going to cover it.
So we know that everyone is interested in performance, so where do IO hooks come into play here? If you remember correctly from our first example where we introduced you to IO hooks, we said that you can technically put whatever code you want into the hook itself. That's true, but you do want to be careful here. Because the IO hooks run synchronously, you don't want to generally put expensive operations here because the IO operation stops to give time for your IO hook code to run. So you generally don't want to do like an expensive, say, a database write or an API call, for instance.
So what's the mitigation? Just keeping this hook super light?
Yeah, essentially, that's really all you can do. You can technically also do, for example, a memory buffer so that you store it into memory and only do a write to, let's say, a database every 50 or 100 IO operations. So it doesn't do this expensive operation every single time your hook runs. You generally just want to wait because you'll increase your performance and your customers will definitely be very happy. All right, we want to thank you once again for tuning in on this episode of DBL Talks. We had a lot of fun making this episode, and we want to invite you to look into our documentation and to explore IO hooks yourself because there's a lot more that we did not cover, like IO event masks that let you selectively turn off IO hooks for certain operations, or an IO flag to see what kind of read it was. So yeah, it's a big world out there.
Yeah, we appreciate watching DBL Talks episode 3. As Daniel mentioned, please do look around in our documentation. There is a lot to consume here. And please do look around the channel and additional information on Synergex.
Yeah, happy coding.
Happy coding.